first thing is this guy over here. Okay. So when we're working in equation work, we have a whole bunch of different equations that we could be doing. And in grade 10, they like to muddle them all together. So we need to know when to do what. And if we see an x squared somewhere, so if it's like an x squared or an a squared or a y squared, it doesn't matter as long as there's a square, that needs to jump out into our brain and tell us that it is a quadratic equation. Okay, and if it's a quadratic equation, there are sort of three things that are quite important. The first thing is we need to move everything and make it equal to 0, which we're going to talk about just now. The second thing we need to think about is we're going to need to factorize. We're going to need to bring in all of that work that we learned in grade 8 and grade 9 in how to factorize. And then the third thing we're going to need to keep in mind is that we're going to have two answers. Those are like the three things we want to think about. So whenever there's a square, when there's an x squared, y squared, a squared, if there's a square, our brain needs to think quadratic. Okay. So if we're having a look at this, we've got x squared minus 13x plus 36 equals 0. It's already equal to 0, so our first step is done. Now we need to factorize. How do we factorize x squared minus 13 plus 36? How would I factorize that? What type of thing is that to factorize? Good, so trinomial. Excellent. What are the factors of 36 that we're going to care about? What factor pair of 36 is going to give us 13? Good, 4 and 9. Excellent. Okay, so we're going to have x minus 9, x minus 4, and that's going to be equal to 0. So remember your cross method. If they're both x's on the side and we're splitting up our factors of 36, if I have a 9 and a 4, we multiply. So x times 4 would be 4x. We need both of those to be negative because we need a negative 13x. Okay. When we get to this point over here, either this bracket would be equal to 0 or that bracket would be equal to 0. The reason we know that is because anything times 0 is 0. If I have 5 times 0, it's 0. If I had 0 times 9, it's 0. So one of these brackets needs to be equal to 0. So we can say x minus 9 is equal to 0, or x minus 4 is equal to 0. So we've got our two different answers. So that's 0.3 that I was talking about. Now it's just a normal linear equation. So we move that 9 over. So therefore, x is equal to 9. Move that negative 4 over, or x is equal to 4. And so those would be our two answers. Okay. So a very quick run through of how to do a quadratic equation. But the most important things are here. So just think about them. You look for your square, it's a quadratic. If it's quadratic, move everything and make it equal to 0. Sometimes we have to simplify at some point. Then we need to factorize, and then we want to get our two answers. Okay. Cool. Let's give one a go. Just gonna zoom past this for today. Okay, let's have a look at this question over here. This is very similar to what we've just done. I want you to try this by yourselves now. First of all, we know that it is quadratic because we have this x squared. It is already equal to 0. So the first step is done for us. Cool. That means we need to factorize and we need to get our two answers for x. So that is what I want you to try and do here. Factorize and get your two answers for x. And if you're feeling good, you're welcome to put your answers in the chat. You can also pop your hand up. We can chat about them. For those of you who've just joined, hi everyone, I'm Teacher Jen. I'm just with you for today. Yeah. Hello. Batu, yes. Have you got answers for me?
Hi, ma'am.
Hi.
Ma'am, I got the answer, yes.
Okay, tell me what I'm going to do.
You're going to open your two brackets, obviously. And then you have x plus 9, x minus 5.
Beautiful. Why is the 9 positive and why is the 5 negative?
And because 9 minus 5 will give us a positive 4, and then 9 multiplied by negative 5 will give us negative 45.
Yes. Okay, excellent. Where do I go to from here?
And then we're going to say x plus 9 is equal to 0, or x minus 5 is equal to 0. Therefore, our x is equal to negative 9, or x is equal to positive 5.
Woohoo! Nice job. 100%. Superstar. Look at you. Love it. Okay, let's see. How we would get marks here is our first step we'd get a mark for being able to factorize that correctly, and then you would get a mark for each one of those answers at the end. How are we doing so far? Did this feel okay? Can you give me an idea of what you got for this? 1, 2, or 3 out of 3? 0 out of 3? 7 billion out of 3? How did we feel? Give me an idea. Nice. Good. Cool, cool, cool. Infinity. Excellent. That feels like you can give this next one a try then. Just going to keep this on the board for those of you who still needed to take some things down. So question 2, we've got 9x squared is equal to 25. Now again, we've got this x squared, which is telling us that it is quadratic. So think about what we need to do if it's quadratic. We need to move everything to one side. We need to factorize. We need to get our answers. So think about what we're going to do for this question. And if you're feeling good and you're feeling confident, pop that hand up and we can talk through it once you're ready. But finish the whole thing first on your side before you put your hand up. Okay, so Tabani, you could square root. My hesitation with square rooting in this situation is that often you forget that there would be 2 different answers. And things get a little bit messy. I'll show you the way you can do it if that's sort of your preferred method. But the best way to do it would be to move that 25 over and then do dots. Exactly, Simtanda, exactly. Move that 25 over. So if we've got that 9x squared minus 25, then we can do dots from there, which just makes our life a little bit easier. Because we can square root, but often what happens is that people miss out one of the answers. Yes, Rita, how can I help? Or are you going to talk about this answer for me?
Hi, ma'am. May I please answer the question?
Absolutely. Tell me what I should start doing.
Okay, so what I did first was I took the 25 onto the left-hand side and made it 9x squared minus 25 equals 0. And then I said 3x. Okay, then I used difference of 2 squares. And then I got 3x plus 5.
Just hold on for 10 seconds, just for the question that's come out yet. Dots is difference of 2 squares. The D stands for difference. The of is just of. The T stands for 2, and then the S stands for squares. Okay, keep going.
And then I said 3x plus 5, 3x minus 5 equals 0. And then I said 3x plus 5 equals 0, or 3x minus 5 equals 0. And then I took the 5s over, and then I said 3x equals negative 5, or 3x equals 5. Then I divided both of the numbers by 3, sorry. Then I got x equals -5/3 or x equals 5/3.
Perfect. Excellent. Nice job.
Yeah.
Totally perfect. 100% in every way. Okay. So give yourselves a mark for getting it into standard form over there. So sometimes your teachers may call this standard form. Okay, so standard form is when we're dealing with a quadratic and it's equal to 0. Then give yourself a mark for doing your dots over there, and then give yourself a mark for each one of those answers. No, if your signs were the other way around, so if you said 3x minus 5 and then 3x plus 5, that's 100% fine. That doesn't matter at all. If you were doing it the way where you square rooting from the beginning, so let's say we had this 9x squared is equal to 25. Okay, the reason I don't like suggesting doing it this way is because if we just always remember that we have an x squared, we move everything to one side and make it equal to 0. It's like a set thing that we know we do. And so we never fall into the trap of not having all of our answers. But if your teacher is a teacher who likes to do the square rooting, this is not wrong by any means. It's just easy to forget an answer. So the first thing we would do is we'd want to isolate the x squared. So we would say x squared is equal to 25/9. Now, in order to get that x to be alone, we would square root both sides. But when we square root, we can get a positive answer or we could get a negative answer. Okay. And so our final answer would be positive or negative. The square root of 25 is 5 and the square root of 9 is 3. But we would get both of those answers. So it's the negative and the positive. Just doing it in a slightly different way. But my recommendation is this way on the left. How did I get the 3x plus 5? What we did was we square rooted that. And that gave us those first two terms, and we square rooted the second term, and that gave us the second terms. So that is just factorizing here. So Michael, this is working with different equations. These are different quadratic equations that we're working through at the moment. Okay. Cool. If you want to take a screenshot, please feel free. I'm going to just scroll down a little bit so you can see question 3. So for question 3, there are actually 2 ways of doing question 3, but one of them is a little bit sneaky. So my recommendation with question 3 would be to start by looking at that x minus 6 and simplifying it a little bit, if that helps. So see how we could write that x minus 6 squared in a slightly different way. Think about if you were given that like normally, what would you do? Yes, we expand. Excellent gift. Excellent. So if we have that x minus 6 squared, remember, we can't just say that that's x squared plus 36. We need to write that bracket out twice, and then we need to do our FOIL. Okay. Just remember, and you don't have to, if you do this a slightly quicker way, you're welcome to. I'm just going to write it out like that for you. And I'm going to move that 1 over. So I'm going to say minus 1 is equal to 0. Okay, so now I want you to focus on your FOIL over here so that everything is out of brackets. We don't want anything in brackets. Then I want you to think about grouping together your like terms, and then you're going to factorize. So we're kind of taking a step forward and then taking like back forward, until we finally get to the answer we want. Samuel, that's great. Pop the answer in the chat for me. I will also show you guys a sneaky way of doing this question, just for those of you who are interested, because it is quite clever. You guys are doing great. Yes, Courtney, my love, how can I help?
Hello, ma'am.
Hi.
Ma'am, can you please go back to question number 2? It's
Sure.
a bit confusing.
So I won't have time to explain it again. Remember, these videos will be online within 24 hours. You can listen to it again, but if you're wanting to see what I've written, you're welcome to have a look and see what's there.
All right, ma'am.
Okay. So Michael, you're kind of doing both. You're expanding, and then you're simplifying, and then you're factorizing, and then you're solving for X. So yes to everything that you've said. So this first step here, we're expanding. Then we're going to simplify because we're going to group together our like terms. Then we're going to factorize, and then we're going to find X. So our expanding is what we're doing in this step here by doing our FOIL. So we're going to multiply those first two terms. We're going to multiply our outer terms. We're going to multiply our inner terms, and then we're going to multiply our last terms. I'm going to give you guys 1 more minute to try and work through this, and then I'll start talking you through what to do on the board. So expanding is whenever we're going from one term to multiple terms. So like if I had 2x plus 3, that is one term at the moment. And if I expand it, I'd be doing distribution. So I'd have 2x plus 6. Now I have 2 terms. That's why we call it expanding. So we're going from one term to multiple terms. So at the moment, this x minus 6 squared is one term, and we're wanting to split it into multiple terms. Okay, so if we just look at this FOIL over here, we would have x squared minus 6x minus 6x plus 36. So that's what this is expanding to. Yeah, Lucia, I'm here. Surprise! And then we have minus 24 and the minus 1. I'm just going to keep it as those numbers for now, and that's equal to 0. Okay, so that was my FOIL. Now, so what we've done here is we've expanded. Okay. Next step is we're wanting to simplify. So we want to group together our like terms. So we've got an x squared over there. That's our only x squared. We've got negative 6x, negative 6x. Those are our x's. And then we've got 36, negative 24, negative 1. So now we're needing to simplify. So we're going to simplify in this step over here. And then once we've simplified, we are going to factorize. And then we are going to solve for x. No, I'm not here for good. I'm just here for today, just like a little guest teacher for the day. Okay, so we're going to have x squared. Then we have negative 6 minus another 6, which is negative 12x. Then we've got this 36. So we have 36, we're minusing 24, and then we are minusing another 1, and we are going to get positive 11, and that is equal to 0. Okay, so all we've done there is we simplified by grouping together our like terms. Now we need to factorize. So what we have here is we have a trinomial, and we need to factorize our trinomial. So we got to factorize it. So factorize our trinomial for me, get me my 2 brackets. Tell me what we're going to land up with. Yes. Spoko, how can I help?
Ma'am, how did you get the 11?
So I took this 36 and then I minused the 24 and then I minused another 1.
Oh, thank you, ma'am.
No problem. Oh, Katiso, so close. Just be careful with those signs. Remember, when this is a plus sign, it means that my signs and my brackets have to be the same. So I'm going to have x minus 11 x minus 1, and that's going to be equal to 0. So that was my factorizing. And now we are going to solve for x. So we're going to say x minus 11 equals 0. Oh, let me write my or x minus 1 equals 0. And so x equals 11 or x equals 1. And that's the whole thing. So that is what our quadratics look for. Yeah, let's put our therefores. Cool. Okay, so from here, we are going to move on to, oh no, I definitely don't want to hurt Coco by not putting my therefores. I will be much
She
more
is
careful with them.
obsessed with the therefores.
I'm going to be so careful, guys. I'm terrible with therefores. It's like my Achilles heel. How much would this question be out of? Let's have a look. So you would get a mark for expanding. You would get a mark for getting into standard form. You'd get a mark for factorizing. And depending on where this was in the exam, you would either get 2 marks for your answer or you would get 1. So this would be between 4 or 5 marks, somewhere in that range. Yes. How can I help?
wanted to know if it's wrong if you don't put the therefore.
So it depends. Some of your teachers are quite strict about therefore signs. They wouldn't take a mark off for not having a therefore sign, but it is kind of like having a sentence without a proper full stop, if that makes sense. So it's like, it's not that it's wrong. A sentence is still a sentence, but like it should have the full stop. Does that make sense?
Okay, thank you.
Okay. Okay, guys, we're going to take this now into some fractions. So we're going to move from here into some fractions, and then hopefully we're going to have time to just do one example of how to do some simultaneous equations. We're not going to do a brain break today. I'm just going to warn you now that I'm going to scroll through it. So you're going to see it. I'm telling you now it's not happening. We've got too much to get through, guys.
It's hectic.
Okay, so don't yell at me when you see it. It's not happening. Just pretend you did not see that. Because we got no time, guys. Grade 10 is stressful. We got a lot of maths we got to get through. Okay. When we are in a fraction equation situation like this, there are a lot of things that we can do. Okay, there's a lot of different ways we can approach this. Generally, the easiest thing to do is to first see if you can simplify the fraction that is happening on the left. If you can simplify it, you're going to try and simplify it. If you can't simplify it, then you're going to want to get a common denominator. Okay, so when we have a fraction equation, so this is when there's a fraction equation. Let me just write this. Fraction equation. Our first goal is if we can simplify, and generally what I mean by simplifying is we're going to have to factorize at some point. Okay, and if we can't, we're going to want to get a common denominator. All right, so if we have a look at this fraction that's chilling on the left-hand side, how can I factorize that numerator? What could I do to factorize that numerator? I've got x squared minus 2x minus 3. How can I factorize that? Who can tell me what to do? Good, it's a trinomial. What would it factorize down to? What would be my 2 brackets? X minus 3, x plus 1. Excellent. X minus 3, x plus 1, all over. I'm going to chuck this guy in brackets. I'm just going to say x plus 1 in brackets. and that is equal to 0. Okay, when we get to this point over here, now we've got this x minus 3, x plus 1, and x plus 1 at the bottom. What happens with those two x plus 1s? Yes, Sadula, absolutely. They cancel. They go away. Okay, it's like if I had 5 over 5, 5 divided by 5 is 1. It cancels. Okay, so we are left with just x minus 3 is equal to 0. Now my question to you is, oh, is this my rule? I know. Is this a quadratic equation or is this a linear equation? Which one is it? Is it quadratic or linear? X minus 3 equals 0. CM Tanda says linear. Good, 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 good. It is linear because that is an x. It is not x squared. Okay, if it's linear, we have one answer. So we're going to move that 3 over. So x is equal to 3. Final answer. Oh, it's not upset Coco. Therefore. Not so bad, right? I didn't. I put it there. I put it. I was a bit late, but I remembered. Okay. Yeah, not so bad. Okay. Let's have a look at number 2 then. Now, number 2 is a little bit different because there are different things happening on both sides. Okay, there's a lot happening on the left-hand side, but we also have a 1 on the right-hand side now. It's not just a 0 anymore. That can be a bit confusing. We're like, I have no idea what to do. So let's try and think about the 2 things we spoke about when we started. The first thing that we said was if we can simplify the fraction, that's big fraction on the left, let's try and simplify it. Okay, so if we're having a look at this, at the moment, factorizing is not going to help us much, but is there something that I could do on this left-hand side with that to try and simplify it out? Yeah, I can multiply that 3 in. I can definitely do that. Okay, so that's something I can do. Then the second thing we spoke about when we had a fraction equation was this idea of getting a common denominator. So right now, on the right-hand side, that 1 would be over 1. So its denominator would be 1. If I'm wanting it to have a common denominator, I want it to have a denominator of 3a plus 1. So think about how we could do that. Those are my 2 hints to you. So think about how we could deal with that 3a plus a squared plus 1, and then think about what we could do if we want to have a common denominator. I'm not going to let you suffer on this one too long. I'm going to talk you through it because I don't want people to make mistakes. The next one, I'll let you try all by yourselves. Yeah, Zenokukle, how can I help?
Hi, ma'am.
Hi.
Ma'am, in the first sum, ma'am, may I please ask what happened to the x squared and the negative 2x?
Okay, so that x squared minus 2x, these 3 terms over here, we factorize them as a trinomial. And when we factorize them, we got those 2 brackets. If that's something that feels a little bit uncertain to you, then there are, I know teacher Coco spent quite a bit of time on factorizing, and also there's grade 9 lessons on factorizing. Both of those might be a good idea to go through from the Watobe website. Yes, I'm seeing some great suggestions here in the chat about what to do with this 1. Okay, so the first thing I'm going to do is I'm going to do my distribution over here. So I'm going to multiply this 3 into both of those. So I'm going to get 3a squared plus 3, and then I've got this plus 10a, and all of that is over 3a plus 1, and that's equal to 1 over 1. Now, if I wanted it to have a common denominator, that means I need to multiply this. We have a little time sign there. I need to multiply that by 3a plus 1. But what I do to the bottom, I have to do to the top. Remember when we do common denominators, so I need to multiply that by 3a plus 1 as well. So what I land up with is 3a plus 1 at the top over 3a plus 1 at the bottom. What I have now is I have a common denominator. Okay. When we have a fraction equation, only when we have a fraction equation, when we have a common denominator with a fraction equation, we are allowed to drop the denominator, but only in an equation. Okay, so now I can drop that denominator completely, and I can just say 3a squared plus 3 plus 10a is equal to 3a plus 1. So now I'm going to drop that denominator. From here, I want you to try and take it from yourself. So we've got an a squared that's telling us that it is quadratic. That means we want to move everything to one side and make it equal to 0. Absolutely. If you want to write the denominator, you can, but for your final answer, you would need to remove it. Exactly. So Braden, once we have a common denominator, so like here, this 3a, oh goodness, why is it not coloring in for me? That 3a plus 1 is the same as that 3a plus 1. So that is our common denominator. Once we have a common denominator, so it's the same on both sides, then we are allowed to drop it. So once it's the same on both sides, then we can drop it. And we only need to worry about our numerators from here. So now when we're at this point, now we can see it's a quadratic, so we want to move everything to one side. So we've got our 3a squared plus 3 plus 10a minus 3a minus 1 is equal to 0. Now you want to start linking together your like terms. So we've got 3a squared, we've got a 3 and a minus 1, and then we've got a 10a and a minus 3a. Link together those like terms. And then we're going to need to factorize. So this one would be worth a lot of marks because there's a lot of things we would have to do in order to get to our final answer. Sure. So all we're doing in this step is we are moving everything onto the other side. So we're just moving everything onto the left-hand side so that it can be equal to 0. No problem. So we're going to have 3a squared plus 7a plus 2 is equal to 0. And then we're going to need to factorize that. We're going to need to think about our little cross. So we're going to have 3a and a. We're going to have to have a 2 here because that 3a times 2, that's going to need to give us a 6a. And then we would have a 1. So, oh, goodness gracious. So 3a. Let's see if I can move this a little bit. Hold on. It is a big one. So we're going to have 3a plus 1, and then we're going to have a plus 2 is equal to 0. And so then we're just going to split that up. So 3a plus 1 is equal to 0, or a plus 2 is equal to 0. Therefore, 3a equals -1, -1 over 3, and this side a is equal to -2. Okay, so the 7 came from saying 10 minus 3. That's where that 7 came from. And the 2 came from, so let me show you what the colors were. The 3 minus 1, that's what gave us that 2. And the 10 minus 3, that's what gave us that 7. The reason we use the 1 and the 2 is because they need to be the factors of 2. So the only factor pairs of 2 are 1 and 2. That's the only pair we have. And we needed to put the 2 so that it would multiply with 3, so we'd get a 6. No problem. Okay, so give this one a like have a look through it. Make sure you're happy with everything that's on the screen. Good. I'm glad it is helpful. I know that it's feeling like we're going fast. I do understand that. But it's important for us to just try and understand what's popping on, what's going over. No, so the reason it's not going to be a -7a is because we've got positive 10 minus 3. So the positive 10 is much bigger than the 3. Why is it positive 2? Because we have, again, positive 3, and then we're only minusing 1. So these brackets come from here. So as we do our cross method for doing our trinomial over there. Yeah, Nam, how can I help?
Normally when you do trinomials, right, you would use the third term to find out, like you use the multiple to find out the second term. So why didn't we do that for this one? Then?
We are. So we're using the factor pairs of our 2. That's our third term. That's the 1 and the 2 in order to get the second term, which is the 7. Just when we multiply like this, the 3a times the 2, that gave us 6a, and the a times 1, that gave us a, and so then that gives us our 7a.
Oh, okay.
Make sense?
Yes, ma'am. Thank you.
No problem. All right, guys, let's try and move on to another one. I'm going to give you one that I want you to try by yourselves from here. And then we're going to see what our time is like so that we can maybe pop in a simultaneous equation. Remember that these lessons will be online in less than 24 hours. So if there's something that you want to hear again, you're able to watch it again and pause when you need to pause, sort of listen to it all a little bit slower if that's something that you're needing. So don't panic. But I'm very glad for those of you who are understanding or finding it helpful. That's great. Okay. I just want to look and see what this question over here was like. Okay. Okay. So when looking at this question, just going to move this guy. I'll move him now. When looking at this question, again, we're needing to find a common denominator, okay? But at the moment, we've got this x squared minus 5x, which is like just sort of bugging us because we could make our life a lot easier. So the first thing we want to do in this situation is we want to think, how can we factorize that x squared minus 5x? Who can tell me how I can factorize that? How can I factorize that x squared minus 5x? What can I do? Great. HCF. Beautiful. Okay. So what we're going to do, I'm going to move up here so I've got a bit more space. Okay. First thing I'm going to do is I'm going to say 4 over x minus 5 minus 10 over x is equal to 2 over x minus 5. Okay. So all I've done in that first step is I've factorized that denominator. Okay. Who can tell me now So I've got these three fractions just chilling. What is my lowest common denominator? What is my lowest common denominator? Yes! Sarah, it was amazing. My lowest common denominator is x minus 5. That is my lowest common denominator. Okay, so we need to look at each of these terms and think, what is each of them missing? So if we have a look at this first fraction over here, okay, so I'm going to write it out like this. We've got 4, and then we've got x minus 5. What is missing in this denominator? What is missing in this denominator compared to our LCD? What do I need? Good, it doesn't have the x. Okay, so we're going to multiply that by x. But remember, what we do to the bottom, we have to do to the top. Okay, now we're going to write our next one. We've got this minus 10 over x. What is missing in that denominator compared to our LCD? Good, the x minus 5. So we're going to multiply that by x minus 5. And we need to do whatever we do to the top that we did to the bottom. Okay, and that is equal to 2 over x minus 5. Is there anything missing in this denominator over here compared to our LCD? This x minus 5. Is there anything missing? No. So we don't need to do anything to it. Okay. Now, in this process, we have made everything have a common denominator. So we can actually, from this point, drop our denominator. But if you feel stressed about dropping it at this point, you don't have to. We can still write it and drop it later. So we're going to have 4x over x minus 5 minus 10 times x minus 5 over x minus 5 is equal to 2 over x minus 5. So as you can see, all of our denominators are the same. And because all of our denominators are the same, we are allowed to drop them. So we just have 4x minus 10 times x minus 5 is equal to 2. What am I going to do from here? Remember, we're trying to solve for x. What am I going to do from here? I know we've had to do some super confusing things to get to this point, but from this point, it's actually something that we would have done from grade 8. Good. We need to expand out the brackets. We need to take this 10 and we need to multiply it into that bracket over there. Got to expand it out. So we're going to have 4x minus 10x plus 50 is equal to 2. So all we've done is we've expanded that bracket. Now my question to you is, because I'm seeing some people in the chat say we need to move the 2 over. So my question to you now is this a quadratic equation or is this a linear equation? Is this quadratic or is this linear? Good. Okay, it's linear because there's no x squared. There's only an x. Now we only need to move everything to one side and make it equal to 0 if it is quadratic. Because it is linear, we can move that 50 to the other side. Okay, so we're going to have this 4x minus 10x. I'll highlight them so you can see that they're the same. The 4x minus the 10x, that's going to be equal to negative 6x. And then when we move that 50 over, we're going to have 2 minus 50, which is going to become negative 48, because we're going to minus that 50 from the 2. Now I've got negative 6x equals negative 48. How do I get that x to be alone? How do I isolate the x at this point over here? Think about grade 8. We're good. We're going to divide both sides by negative 6. Okay, so those are going to cancel, and we are left with x is equal to positive 8. It is a hectic question, guys. I'm going to show you where you would get all your marks for a question like this, but it is a lot. There's a lot that you have to think of. So you would get a mark for factorizing that denominator. You would get a mark for getting to this point of the negative 10 times x minus 5 and getting to the 4x. You would get a mark for getting to this point over here of the negative 10x plus 50. And then you would get a mark for getting your final answer. So you're looking at 5 marks for a question like this. Yes, Kirata, how can I help?
Ma'am,
I was asking what happened to the denominator, the x and the x minus 5.
So once the denominator is the same on all of our fractions, then we're allowed to drop it. We're allowed to take it away.
Oh, and
But-
then what happened to the 50 and the 2?
So I took that 50 to the other side. So it became 2 minus 50. And that 2 minus 50 became the negative 48.
Oh, thank you, ma'am.
Okay, cool. Cool. Does anyone have any other questions about this one before we move on? Cool. Okay. So the last little thing that we're going to be dealing with today, so the first thing we dealt with was just normal quadratic equations. Then we moved into some fraction equations, so looking at how we can use factorization in equations to understand how things are working. And the last thing we are going to look at today is simultaneous equations. Okay, simultaneous equations are when we are given 2 different equations and we have to solve for x and y. So we are given 2 equations and we have to solve for x and y. So here we've been given 2. We've been given y equals x plus 4 and y equals negative 2x plus 1. And from here we need to try and figure out what we want to do. Okay. So let's just try and move this like this. When we're working with simultaneous equations, there are different ways we can go about it. You must do the way that you're comfortable with. Sometimes in class, your teachers are going to want you to do a specific way. And so sometimes we have to do with whatever our teacher is wanting us to do. Okay, so I'm going to show you both ways. We're not going to have time to go through questions of this. We're just going to do this as like an example of how we do simultaneous equations. And then I'm sure Teacher Coco will start your lesson next week by doing one with you guys together. Okay. So these are the 2 equations that we're working with. If we are doing substitution, there are lots of different ways we could go about it. But this first equation is telling us that the value of y is x plus 4. That is what y is. I'm sorry, Michael. Teacher Coco will be back on Monday. I promise. I promise. I'm just here just for the day. So this equation is telling us that y is equal to x plus 4. This is that same y. So y is x plus 4 and x plus 4 is y. We can then use substitution to say that they would be the same thing. So what I mean by that is if we have a look over here, we're saying that that is y and that is y. So actually what I could say is instead of writing that y, I could say that that is x plus 4. And that would be equal to negative 2x plus 1. So all we're doing in this step is saying, instead of writing that y, we're saying, but we know that y is equal to x plus 4. So instead of writing y, we're just going to write x plus 4. So the reason we're doing that is because we only want one variable. Okay, we don't want to have the X and the Y. We only want to have one variable. And in this case, our one variable is going to be X. The reason we only want one variable is because then we're able to solve it. Okay. So instead of writing that Y, we've put that X plus 4. What type of equation do I have now with X plus 4 is equal to negative 2X plus 1? What type of equation is that? Is it quadratic? Is it linear? Yeah, exactly. It's linear. Okay. So if it's linear, we want to move our X's onto one side and we want to move our numbers to the other side. So I'm going to say X plus 2X is equal to 1 minus 4. So I've moved my X's onto one side and my numbers onto the other side. So X plus 2X is going to give me 3X. And that is equal to 1 minus 4, which is equal to negative 3. And so X is equal to negative 1. Okay, cool. But we haven't finished our full answer here. At the moment, we only know what X is. Now we need to figure out what Y is. So now we need to go back to one of our original equations. So now we're going to go back to saying what Y is. Let's move this down. So Y is equal to X plus 4. But we know that X is negative 1 because we've just solved that. So we can say Y is equal to negative 1 plus 4, which means that Y is equal to 3. And so now we've solved for X and we've solved for Y. And that's how we do a simultaneous equation. Simultaneous equation, we get two answers, one for X, one for Y. Yeah, exactly. It's so nice and easy. So that's how we do it with substitution. I'm just going to quickly show you what it looks like with elimination in our last little time. And then I'm sure Teacher Coco will carry on with this with you next Monday. Okay. Yeah, it is. But can I tell you the cool thing, guys, is that simultaneous equations stay with you until matric. And they are like a guaranteed 6 marks in your final matric exam. And it's the same concept that you do from now. So it's like you get to practice them for the next 3 years. And then you guarantee those marks in matric. Okay, for elimination, we write out both equations. Okay, and our goal is to eliminate one of the variables. So in this case, because our y's are the same as each other, they are both 1y, we're going to try and eliminate our y's. So I'm going to minus this whole equation. Okay. So y minus y, what is y minus y? What would I get? What's y minus y? 0. Beautiful. Okay. Now we've got to be careful. What is x minus negative 2x? What happens when I have that negative and the negative? What does that become? So let me write it like this. It's x minus negative 2x. Good. It's going to become positive. Okay. So what is that going to become? What's x plus 2x? 3x. Beautiful. Okay. And then we have 4 minus 1, which is going to give us our 3. So all we're doing is we're taking that top equation and we're minusing the bottom equation. Normal equation from here. So we're going to have negative 3 is equal to 3x. Same, divide both sides by 3. So x is equal to negative 1. And then we do exactly the same thing we did here. And we just substitute that x into one of the equations. So the only difference with this is that we're taking the one equation and we're eliminating one of the variables by subtracting it. Yeah, David, so substitution for me is 100% my favorite method. Substitution will work with you until your dying day. If I had to choose a method, I would choose substitution, but a lot of people find elimination a little bit easier. And so you must do the one that is easier for you. But yeah, they're both completely fine. Yeah, it would work 100% if you minused the other one. If you took 2 and you minused 1, totally fine. Teams up. Okay, my lovely lambs, I have to leave you for the evening.